Hi, I am K. Sridhar, study in Ashankara Institute of Technology, CSC A section. I am explaining our topic is pipeline and vector processing. Pipeline and vector processing. Pipeline processor. Simultaneously, data processing task for purpose in increases in the computational speeds. Perform concurrent data processor to achieve faster execution time. Multiple function units. Separated to the execution unit to the 8 functional units operating in parallel. Computer architecture classifications. Data instruction stream flying. Series versus parallel processing FENG. Parallel size and pipelining handler. Friends classification SISD means single instruction single data stream. For practical purpose only one process is useful. Example system in this show the diagram. Above SIMD. SIMD means single instruction multiple data stream. SIMD means vector or array operations. One vector operation included many operations on the data stream. Show the side diagram. Explain system. Show the diagram. And another is MISD. MISD means multiple instruction single data stream. Data stream bootline neck. Show the diagram. Above next MIMD. Multiple instruction, multiple data stream, multiple processor system. Show the diagram. Main topics in the character pipeline processing, arithmetic pipeline, instruction pipeline, vector processing, other multiple pipeline, array processing, array processor. Attached any array processor, SIMD array processor. Pipelining means decomposing a sequential process into the sub operations. Each sub process is executed in the special dedicated segment concurrently. Pipeline. Multiple and add operations. AI star DI plus CI are in I equal to 1 to 7. Sub operation segments R1 gives rise to A1 AI, R2 gives rise to BI. Input AI and BI. R3 gives rise to R1 star R2, R4 gives rise to CI. Multiple and input CI. Next R5. R3 plus R4. Content of registers in pipeline examples. General considerations. 4 segment pipelines. Combinational circuits for sub operations, registers. Space-time diagrams show segment utilization as a function of time. Task T1, T2, T3 and so on T6. Total operations performed going through all the segments. Speed up as non-pipeline pipelines. S equal to n into Tn k plus n minus 1 Tp equal to 6 into 6n divided by 4 plus 6 minus 1 Tp equal to 360 Tn by 9 Tn equal to 4. N equal to task number 6. Tn equal to time to complete each task in non-pipeline. Tp equal to clock cycle time. K equal to segment number. If n gives rise to infinity, S equal to Tn divided by Tp. Task non-pipeline Tn equal to pipeline K into Tp. S equal to Tn by Tp equal to K into Tp divided by Tp equal to K. K equal to segment. Pipeline, arithmetic pipeline, instruction pipelines. Arithmetic pipeline, floating pipeline, adder pipeline examples. Sub and add to normalized floating point binary numbers. X equal to A into 2A equal to 0.9504 into 10 to the power of 3. Y equal to B into 2B equal to 0.28200 into 10 to the 10 square. 4 segment Sub operations. Compare exponents by subtractions. 3 minus 2 equal to 1. X equal to 0.9504 into 10 to the power of 3. Y equal to 0.200 10 square. 2. Align mantisas. X equal to 0.9504 into 10 to the power of 3. Y equal to 0.08 into 00 into 10 to the power of 3. Add mantisas. Z equal to 1.0324 into 10 to the power of 3. Normalize the result. Z equal to 0.1324 into 10 to the power of 4. Show the algorithm in this problem. Instruction pipeline. About topic. Instruction cycles. Fetch the instructions from the memory. Decode the instructions. Calculate the effective address. Fetch the operates from memory. Execute the instruction. Store the result in the proper place. Show the algorithm. Example: 4 segments instruction pipelines. 4 segments CPU pipeline. F1 instruction fetch DA. Decode instruction and calculate EA. F4 operate fetch EX execution. Time of instruction pipeline. Instruction 3 branches. Show the diagram. Pipeline conflicts. 3 major difficulties. Resource conflicts. Memory access by 2 segments at the same time. Data dependency. When an instruction depends on the result of the previous instruction, but this result is not yet available. Branch difficulties. Branch and other instructions interrupt the change the volume of PC. Data dependency. Hardware, softwares. Hardware interlock. Previous instruction hardware delay. Operand forwarding. Previous instruction ALU register software. Delayed load. Previous instruction no operation instruction. Handling of branch instructions. Prefetch target instruction. Conditional branch target instruction fetch. Branch target buffer BTB means. Associative memory. Branch target address instruction is BTB. Branch instruction cache. Loop buffer. Small very high speed register file RAM. Loop decade loop. Branch prediction. Branch predictor means additional hardware logic. Show the diagram. Delayed branch. Branch instruction pipeline operating. Non-operation instruction rearranging compilers. Risk pipeline, risk CPU, instruction pipeline, single cycle instruction execution, compiler support. Examples: 3 segments instruction pipelines. Sub operations instruction cycles. Instruction fetch, instruction decode and ALU register. Transfer the output of ALU to register. Delay load. Instruction add R1 plus R3 conflict. Delayed load. Show the diagram. Delayed branch. Same is shown in the diagram. Vector processing. Science and engineering applications. Long range weather forecasting, petroleum explorations, systematic data analysis, medical diagnosis, aerodynamics and space flights, simultaneous, artificial intelligence and expert systems mapping and human genome image processing. Vector operations. Arithmetic operations on large array of numbers. Conversion scalar process. Machine language. Fortran language. Showing initialized I equal to 0, read A, read BA, store Ci equal to A plus BI, increment I equal to I plus 1. If I is greater than or equal to 100 to go to 20, continue. Vector processor, single vector instruction C equal to 1 to 100, A equal to A into A is to 100 plus B is to 100. B is to 100. Above is vector instruction format. Show the diagram. Matrix multiplication. Show 3 into 3 matrix multiplication and square equal to 9 inner products. Simultaneously multiple and add operations. N cube equal to 27 in multiple add. Pipeline for calculating an inner products. Floating point multiple pipelines. Floating point adder pipelines. In the show the diagram. Memory interleaving. Simultaneously access to memory from 2 or more sources using one memory bus system. Even odd address memory access. In show the diagram. Supercomputer equal to vector instruction plus pipelined floating minus point arithmetic. Performance evolution index MIPS million instruction per second. Flops floating point operations per second. Cray supercomputer. Cray research. Clay 80 mega floats 4 million 64 byte volt memory. Clay 2 12 times more powerful than the Clay 1. VP supercomputer. VP 200 300 megaflops 32 million memory, 8 vector instructions, 195 scalar instructions. VP 2605 graphics. Array processing multiplications. A large array data of array processing. Array processing is the auxiliary process attached to the general purpose of computer. Assigned array processor. Computer with multiple processing units. Operation of parallel. Thank you for your given opportunity.